Hey there, TouchDesigner developers. Jack DiLaura here with the Interactive and Immersive HQ. In this video, we're going to look at recreating the style of Manfred Mohr. We're going to create a generative art piece, which you can see on screen, that kind of follows the style that this artist Manfred Mohr was working in during the 1970s, where he would take different cubes in this sort of wireframe fashion, and some of the compositions would have them bisected, some of them would have them kind of cropped, but they all created these cool kind of minimalist compositions in this sort of wireframe style. If you're not familiar with Manfred Mohr, you can check out his website. He is still a practicing artist, still making stuff that kind of follows in this minimalist geometric computer-generated way. You can take a look at his artwork on his site, which is emohr.com, and you'll get to take a look at a variety of his works over the years. All of these early pieces that we're kind of taking inspiration from for this project today were created with a computer, which was then feeding information to a plotter, which would then draw the images on some kind of paper stock, and then he would show those in galleries. So again, this is a super like analog way of creating digital art compared to what we're used to, but it creates a very interesting and unique and minimal style, and I thought it would be kind of fun to recreate in this video. So definitely take a look at his website, and with that, let's jump right into putting this together. Okay, so real quick, here is the network that we're going to be building. It's super straightforward. Unlike Manfred, we do not have to use punch cards and room-sized computers to generate this outcome. It's actually pretty simple to put together. So let's begin by deleting everything from our network and beginning with a box SOP. So the box SOP is going to generate our cubes that will be in our final output. And we're going to modify the size parameter here to set that to a value of 100 for the X, Y, and Z parameters. Cool. Then we'll right click on the output and add a geometry comp and put that to the right. Within the geometry comp, we're going to turn on instancing, because we're going to make copies of this geometry. And then we might as well just set up our rendering pipeline before we move on. So I'm going to grab a camera, and within the camera, we're going to make a couple of adjustments. So in this case, we're actually going to head to the view page and set our projection mode to orthographic. So we're going to have an orthographic view of our final scene. We don't really, I mean, you could use perspective if you want, but orthographic works just fine. For the ortho width, we're actually going to reference the render top that we're going to add in a moment. So we're going to come back to that one. And then on the transform page, we're just going to set our translate Z parameter to 100. So since we need that render top to change our ortho width, let's go ahead and add that next. Head to the top page and grab the render top. Then we'll head to the camera once again and set our ortho width to the parameter within the render top called resolution W. So we're going to type in op, open and close parentheses, and then single quotes, render1 dot par dot resolution W. Should get a value of 1280 at this default resolution. We'll come back and change that in a little bit. And then the final thing I'm going to do here is add a wireframe material for our wireframe cubes that we're going to be generating. We'll put that over to the left of the camera, and then I'll drag that onto the GO1 and select Parm Material. We're also going to set the color within the wireframe to black. Perfect. Okay, so now we are going to generate some instances. If we were to look at this render full screen, well, we wouldn't see anything because unfortunately our Our cube is black right now, but if we were to composite a white background in, we can see here that we just have one cube at the center of the screen right now. So that's not super interesting. So to generate those instances, I'm going to add a grid SOP and attach a null to that, which I'm going to call null space POS for positions. And then we'll come back to the grid. We just have a couple of things to change here. So the way that we've set this up is it's kind of like a unified pixel space. So we have a box that is 100 pixels by 100 pixels by 100 pixels. And we want to create a grid of those boxes, and we want the size of that grid to be 600 by 600. So let's set the size parameters to 600. Now, if we were to take a look at the wireframe of this final output of our null POS, and then head to our display options and turn on the points within this displayer, you can see that we have a lot of different points right now because we have a 20 by 20 grid. So for the final version that I made and that you saw at the beginning of the video, we had a simple 4 by 4 grid. So I'm going to come to the rows parameter and set that to 4 within the grid SOP, and then I'm going to set the columns to 4 as well. Then if we look in our final null POS operator, we have a simple 4 by 4 grid. So now we can actually head back to the geocomp, and on our instancing page, let's drag the null POS operator onto the translate op parameter. We'll then grab the translate X, Y, and Z channels. We'll grab P0 for translate X, P1 for translate Y, and P2 for translate Z. Cool. So one final thing to do here, and that is to add random rotations to each one of these cubes. Right now, if we were to look at our final output, and you know what, let's just composite a background in just so we can see what that looks like. I'm going to add a constant top after our render, and we'll kind of place this over to the right because we're going to insert some additional stuff. I'm going to leave the color as white, and then I'm going to use one of the handy functions here. If we head to the output page, we can do comp with input. We'll turn that on, and then we'll set our operation to over, and that saves us a step of having to use another top to composite those layers together. Actually, I want not the operation of over, but the operation of under in this case. Now, if we were to look at that full screen, you can see we have a very clean grid of squares at the moment. We're in orthographic mode, so we don't really see any of that perspective that you might see in the geo viewer itself. But if we were to add the random rotation to each one of these cubes, then we'd get something that looks a little bit closer to Mohr's artwork. So to do that, I'm going to use a noise chop just because it's easy to use and a pretty simple way to get those rotation values. Within the noise chop, we've got a number of different things to set, but I'm going to start on the channel page. Now, in order to make this function correctly, we need to have the same number of samples within this chop as we do points within our null POS operator. So what I'm going to do first is set the start and end units to samples. And then for the end parameter, I'm going to make a reference to the null POS operator, the number of points within that operator. So we're going to type in OP, open and close parenthesis, single quotes, null underscore POS, and then dot num points. Now this is 0 index based, so I will also have to subtract 1 from the end. And once we do that, we should have an end value of 15. And if we middle mouse click on the noise chop, we should see that we have 16 samples. So that will work just fine. The other thing, well, actually we have a number of things to do before we move on. So before we kind of jump ahead of ourselves here, let's add some additional channels. So I'm going to call these channels ROT, and then the particular axis of rotation that we're going to be modifying. So we'll do ROTX space ROTY space ROTZ. That's found within the channel names parameter on that same page. And then I'll hit enter, and then we should see 3 different channels of noise. Now, because of our current settings, they look pretty smooth and not all that random. But if we were to come to the period parameter and set that to something super small, like 0.0001, we have somewhat of a noisier output. Cool. So we are all set within that operator. I'm going to then attach a math chop. And within this math chop, we're just going to change the output range of these chop channels to give us an actual like visible rotation in our final instance rotation. Right now, they're just falling between negative 0.5 and positive 0.5. So we're going to head to the range page and change our from and to range parameters so that we can get a more noticeable amount of rotation. So first off, I'm going to set my from range to fall between negative 0.5 and positive 0.5. And then in the to range, I'm actually just going to set this to fall between 0 and 90 degrees. We'll take a look at how this modifies our output in just a second. You can definitely play around with that to range value in order to get something a little bit more dramatic, but I found that that looked pretty good and pretty close to the original. So I've then just added a null after the math chop. I'm going to call this one null space ROT for rotation. And then we'll head back to the geo where I'm going to drag null underscore ROT into the rotate op parameter. And then I'm going to grab the rotate X, Y, and Z channels for the rotation parameters. Then if we view our final output, you can see that we now have a different rotation value for each one of these cubes, and they're starting to look a lot more like cubes than they did before. So that's great. Now, one thing that you might have noticed is that our final output is getting cut off a little bit. I used a square resolution in the original version of this, and that's what we're going to do in this one as well. So in the render top, we'll head to the common page, and I'm going to set the output resolution here to 1024 by 1024. And now if we right click and view the constant, we should see that none of our cubes are being cropped anymore. Okay, so we've got our basic composition set up. We have some cubes that are looking, pretty similar to those original plotter-based compositions. But the interesting part really comes into play with bisecting those cubes. The way that we're going to approach this is by using the matte top, which will allow us to kind of splice together 2 different camera angles of our geometric composition that we have set up so far. So we're going to begin by adding a second camera and a render pass top in order to render that second camera angle, and then we will build the matte, which will allow us to splice those images together in an interesting way. So let's first of all grab the second camera. And you know what, I think the easiest way actually is just to copy and paste the camera that's already here, because we already have set up that orthogonal or orthographic rather projection. So copy and paste the first camera, and then because we now have 2 cameras, one important thing to do here is specify within our render top which camera we want to actually be using. And we already have it set up to camera 1, so that's good. But in our render pass top that we'll add in a moment, we'll have to make sure to set that to the camera 2 that we have just added. One other thing that we can do while we're within this render top is actually point it specifically to this Geo1 geometry, because we're going to add, as I was saying, that matte, which will allow us to use the matte top in a moment, and we don't want to render that actually within this render top. So what I'm going to do here is just drag the geo onto the geometry parameter. And with that, we're all good with our first render top. So what I'll do after that is add, by middle mouse clicking, the render pass top that I was just talking about. And in this render pass top, that is where it's important to point to the correct camera. So we want to do something similar to what we just did with the render top. We're going to, first of all, drag our geometry into the geometry parameter, and then we're going to do the same thing with the camera. So I'm going to drag that over to the camera parameter, and then we don't want what's happening right now, which you can't really see. Let me connect this to the constant. What's happening is that, oh, you can't see it anyway because they have the same camera position, but because of the settings within this render pass, we are essentially not clearing our camera and our depth buffer out, which means that if this second render pass had a different angle, so if I come in here and change the rotation to like 180 or something like that, if you look in our final output, those two images are layered on top of each other. And we want to not have that happen. We want to instead have the ability to use a matte top to control that layering. So what I'm going to do within the render pass is turn on clear to camera color and clear depth buffer. And now, since we're connected directly from this render pass to the constant, if I right click and view, we should only see one copy of that geometry. So with that, we can actually go ahead and add the matte top after our render pass. And what we want to do with the matte top is connect the render 1 top to the first input, and then the render pass top to the second input. And then once we get our second sort of instancing set up with that matte that we'll be generating, we'll connect that top texture to the third input. While we're here, I'm just going to add a final null just for good measure. And then let's head back to camera 2 momentarily because we want to actually set that a little bit differently from what we've done here. So I'm just going to take that 180 rotation value out of the rotation parameter. We're going to leave those all at 0. And then I'm going to set the scale for the Y direction to -1, which will effectively invert the image in that direction. So what that means is now we've got two different images of the same scene, but rotated and inverted from each other. And that will be useful with our matte later on. So just scoot those over, and now we can work on that second instancing setup. So the way that I'm going to approach this is instead of copying and pasting just so that we can make sure that everything is set up correctly, let's just start from scratch. It's pretty quick to go through. So down below our first network, let's add a rectangle stop. And in this case, we're going to use a little bit of a different scale from before. We're going to set the size X to 200 and our size Y to 100. Once we've done that, we'll right click on the output and grab a geometry comp, which we'll place over to the right. Now for the render pipeline here, we are going to use actually the same camera 1 that we have already set up before. So we're not going to add a camera, but we will add a material. I'm just going to grab a constant and we'll just drag that onto the geo, set the parameter material for that geo, and then let's add another render top after this geo. So render 2 should be appearing next to geo and geo 2. And again, we're going to need to specify which geometry we want to render, because we don't actually want to render this geo 1 in our render 2 top. We just want to render geo 2. So I'm going to click and drag geo 2 over to the geometry parameter, and now it's only rendering that particular geo. So now, just like in the other situation that we had before, we're going to add a grid SOP to create instances of this geometry. And in this case, again, we're going to be doing something a little bit different. We're going to change our size to 600 by 700. And we're going to set our rows to 8 and our columns to 4. Okay, so now that we've got that completed, let's add a null and again, call this one null POS and hit enter. It'll add a 1 at the end because we already have an operator with that name. I'm going to then head into the geocomp, head to the instance page. We'll turn instancing on, and then I'll drag null POS 1 onto the translate operator parameter and grab translate X, Y, and Z, the P0, P1, and P2 channels, just like before. Now we'll see what looks like a solid square at the center of our screen, and again, within the render top. That's okay. We're going to add we're going to modify the color of these instances with a ramp in just a second. But one thing that I'm noticing that we forgot to do was to modify the render resolution. We actually want to connect that via reference to the render 1's resolution so that they're identical. So we'll come to the common page, we'll bring the click on the resolution title, and within resolution width, we'll say, or we'll type op open and close parenthesis, single quotes, render 1 dot par dot resolution W, and hit enter. Should get a value of 1024. We'll do the same thing for the height, except that we'll change the parameter name to resolution H. And then we should have a 1024 by 1024 output resolution. Cool, so now we can actually add our color. So I'm going to do that with a ramp top. And within the ramp top, let's start by setting the resolution. So because we're going to be applying this to our instances, we need to have the same number of pixels as we have instances. So we're going to connect that to the, in this case, the number of rows and columns within our grid. So what I'm going to do within the ramp is set our resolution values based on those parameters. So in the resolution width parameter, let's type in op, open and close parenthesis, single quotes, grid 2 in this case, and then dot par dot calls. We want the number of columns in that case. So that should be a value of 4. And then we'll come to the resolution height and we'll do the same thing, or we'll paste that rather, and then change the parameter that we're looking for to rows. Once we've done that, we should have a 4 by 8 resolution. Then we'll come back to the ramp page where we'll set our type to vertical. And here we're going to set our period to 0.05 and our interpolate notches parameter to step. Now that'll turn it all black, which is okay because we're going to modify some values within the table below. So we're going to click the little arrow here to bring up the docked keys dat that we have available, and then we'll click the viewer active button, and on the indicator or the label for the first row, we're going to right click on that and hit add below. Then we'll add in a key at 0.5 in the position column, and then we'll do 1 for R, 1 for G, 1 for B, and 1 for alpha. And once we do that, we should see a nice striped output there. And if we were then to come to the common page and turn our input smoothness and viewer smoothness to nearest pixel, we should see this sort of zebra pattern, which will give us the ability to use the matte top in just a minute. So we're actually all done with that operator now. We can add a null, and within, or in the label for that null rather, we're going to call this one null space color, and then head back to the Geo2 comp. where we'll head to the instance 2 page and head to the color section. I'm going to drag the null color operator into the color op parameter, and then we'll grab the RGB and alpha parameters or channels from that operator. So again, we should see that same sort of striped look in our render 2 output. And now if we were to use a select top rather, and bring that texture into our matte and make a couple of settings changes there, we could get that bisected look. So within the matte top, let's set our matte channel to luminance. And then let's right click on null one and hit view. So that's actually it for this video. There's actually a lot you can do to continue exploring with this technique. One of the things that you might see if you start to dive into Manfred's work from that era is that oftentimes he'll be dealing with different line thicknesses. So one of the things I'd suggest taking a look at is using something like the line material, which can change the thickness of the line depending on how far the object is from the camera. That can give you some pretty cool and interesting results. And another thing that a lot of that artwork deals with is clipping of the wireframe. So like certain parts of the cube might be cut off because Manfred set up like a clipping plane in his code. We can approximate a similar sort of thing by using some of the parameters within the camera back in the network. If you take a look on the view page, we have the ability to set the near and far distance to cut out specific ranges that we want to be looking at. And you can do the same thing or emulate a very similar effect to what he was doing by playing with those values. And actually it'll provide you with a result that looks very similar to what we can see in this preview, where you can cut off different parts of the cube by playing with that distance. Of course, you can also play with color. You don't even have to use wireframes at all. You could use constant or Phong or any number of different materials. But this should at least get you started with playing around with creating very minimal compositions, and also using instancing and geometry itself to create these mattes that we can use again to modify that output. So with that, we're going to close out the video. Hope you've enjoyed putting this together and maybe learned something, whether that is TouchDesigner related or a little bit about the world of art. Looking forward to seeing you in the next video here on the Interactive and Immersive HQ. Thanks for watching.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.